today we are moving on with even more exponent laws. Some of these may be familiar to you, some of them may be new. So the first thing that we're going to be talking about is a negative exponent. So you are allowed to work with negative exponents. You would just treat them like any other exponent. The only major rule is that your final answer can never have negative exponents. So you do need to be using this rule to go that one step further and change it a little bit. So the first thing I guess that I'm going to talk to you about is the rule itself. So x to the negative n is equal to 1 over x to the positive n. So basically, if you have a negative in the exponent, you're going to be rewriting it as a positive, but moving it into the denominator, or adding a denominator in some cases. So I'm going to go through just a very basic example here. So if I have x to the 3 divided by x to the 4, I know that since I'm dividing, I'm going to be subtracting exponents, so I'll get x to the 3 subtract 4, which is a negative 1. Now, I see a negative 1 in my final answer as my exponent, and I know that I have to rewrite it as 1 over x to the positive 1. Now I'm going to do another example. So if I have 3 to the negative 2, I need to rewrite that as 1 over 3 to the positive 2, so a 1 over 9. I can continue on here. If I have x squared y to the negative 3 over x to the 4 y to the negative 4, this is allowed. I'm allowed to have a question with negative exponents, and I'm allowed to work with those negative exponents. So don't try and change them right away. You only change them in the end. So I have x to the 2 subtract 4. Sorry, that's a really hard to see 4. But that will give me a negative 2. And then I'm going to have a y to the negative 3 subtract negative 4. So really that's like a negative 3 plus 4. So that's a 1. Now that I'm done and I can't simplify anymore, I do need to move this x to the negative 2 into my denominator. So what's going to happen is my y to the 1 is going to stay in my numerator because it's positive and I don't have to change it, but my x squared needs to move down to the bottom there. Just a couple more quick examples here. So if I have 3x to the negative 2y, and we're just going to pretend that this was like my final answer here. I do want to talk about how we're going to simplify this. So this negative 2 is only with my x. That negative 2 does not belong with the 3. That exponent is only touching or only affecting my x. So that means that the 3 and the y are going to get to stay in my numerator, but this x to the negative 2 needs to go in my denominator as an x to the positive 2. Now the last example that I'm going to go through right here is x over y to the negative 1. Now we know because of previous rules that negative 1 needs to go into my numerator and my denominator. Now since these are both a negative exponent, what's actually going to happen is that this x to the negative 1 that's in my numerator is going to have to go to my denominator and become positive. And this y to the negative 1 that's currently in my denominator is going to go to my numerator and become positive. So you can basically think of this rule as if something's in the numerator and a negative exponent, you need to switch it to the denominator. And if something's in the denominator with a negative exponent, you need to switch it to the numerator. The next law I'm going to be talking about is the rational exponents. So when your exponent is a fraction. So the law says x to the power of m over n is equal to the nth root of x to the m. So whatever your numerator was is your exponent, and whatever your denominator was is the little number that goes outside of the root. Now we can also rewrite this rule a little bit different. So we could have the nth root of x, and then that entire thing can be to the exponent m. You get the exact same answer regardless. So we'll do a couple of examples, and I'll show you both ways so that you can see what I'm talking about. So our first example is going to just be an easy one. So 9 to the 1/2. Now, this is technically a little 2 because that's my denominator outside of my square root with a 9 to the power of my numerator, which is a 1. But in reality, if we write a square root, we just assume that there's that little 2 there. And we obviously don't need to write an exponent of 1. So this is the exact same as if I just said root 9, which we all know is just 3. The next example that I'm going to do, I'm just going to stick with a numerator of 1 here. So we'll do 8 to the 3rd. Now, this means that I have a little 3 outside of my root sign and an 8 to the power of 1. So this is the cube root of 8. So we basically need to say what times what times what gives me 8. So the answer is 2. 2 times 2 is 4, times 2 is 8. Or obviously you can use your calculator. My next example is going to be 8 to the 1/3 to the 4. We know that when we have a power of a power like this 4 needs to be multiplied by the 1/3. So this is going to be 8 to the 4/3, which we can rewrite as the cube root, because my numerator is 3, of 8. Now we have options here, so option 1, we can put all of that to the power of 4, or, and I'll leave a little bit of space here, we can do the cube root of 8 to the power 4. So I'm going to go ahead and I'm going to finish option 1. So the cube root of 8 is 2, and then we'll have to the power 4, which 2 to the power 4 is 16. Or we can do the cube root of 8 to the power 4. So 8 times 8 times 8 times 8 is 4,096. And then if you're using your calculator, the cube root of 4,096 is 16. So obviously, either answer will give you the correct answer, but probably this would have been easier just because you're cube rooting the number first and dealing with smaller numbers. In this first example, I'm going to go ahead and I'm just going to throw all the rules at you in one big old question. So we have 49 over 81 to the negative 3/2. Now, the first thing that I need to do is change this negative exponent. This is as simplified as it can get, so I need to go ahead and switch that right away. Now, we haven't really talked about something like this. We know that when I'm switching a negative exponent, the numerator needs to go to my denominator, and my denominator needs to go to my numerator. And so this can be rewritten as 81 over 49, and instead of now my negative 3/2, I get a positive 3/2. Next, I can go ahead and I can bring this 3/2 in, and because of my rules last week, I know I need to bring that into my numerator and my denominator. So because my denominator is a 2, I'm going to have the square root of 81 to the power of 3. And then I'm going to have the square root of 49 to the power of 3. The square root of 81 is 9 to the power of 3. The square root of 49 is 7 to the power of 3. And then if I go ahead and use my calculator there, I get 729 over 343. When I look at this next example, it just says write as a single power, same base. So right away I can see that I do not have the same base. One is a 32, one is an 8. If I look a little bit further, I see that I can rewrite these as the same base. I'm taking the 5th root of 32 squared. Now, if I do the 32 squared and I take the 5th root of that, I don't get what I need. And so if I do the 5th root of 32, I know that that's a 2. So here I'm doing the 5th root of 32, which is 2, and I'm keeping my squared there. Next, I'm going to do the cube root of 8, which is 2. Now, we know that this has an imaginary 1 right here. So when I go ahead and I simplify this even further, I get 2 to the 2 plus 1, which is 3. Now, since it says right as a single power, I'm done at this line. I wouldn't go further and simplify to be 8.